To calculate the area of a triangle, or to calculate any area, what I need to do is make squares, or measure squares, the number of squares that fit into that shape. And to make squares, I need 90-degree measurements. So I need to use two lines that are 90 degrees to each other. Length times width will give me the number of squares. So in this case here, if I use 21 and 15, that's not a 90-degree angle, so this is not going to make squares, so this is a problem. So I need to be able to drop down my perpendicular here. And if I drop my perpendicular down, it does kind of two things. First of all, I need that 90-degree line to be able to make squares. And secondly, it generates a right triangle for me here. And that right triangle I can use to solve for the height, which I'm going to call x. So now this is very important that I always have to use 90-degree lines to be able to calculate area. When I look at this, I've made my triangle, and I'm going to involve the sides opposite and hypotenuse. So katoa, opposite and hypotenuse go with sine. So x compared to 15 is equal to sine of 55 degrees. So that ratio, when I plug it into my calculator, I get 0.8191. So I'm going to round that to 819. And 819, and that's a ratio to 1. I can solve this as a proportion, or I can solve it algebraically. Here I'm just going to multiply both sides by 15 and solve it algebraically for x. And I end up with my x length being 12.29. So there it is. I've got calculated my height of 12.29. I have my base here of 21, so I can then calculate the area of a triangle by length times height, base times height divided by 2. So my area of the triangle is equal to the base of 21 times the height of 12.29. Again, the height has to be the 90-degree height, it can't be the 15 here. And then dividing it by 2 will give me the number of squares that make up that space. Okay, so in this case I end up with 129.0126, so I'm going to round that to 2 units squared, and that represents the number of squares that make up that area. And again, the key to this is to be able to drop down your perpendicular, okay, from the vertex down, just like what we did with solving these non-right triangles, to generate the height. And by generating the height, we also generate a right triangle, which we can use ratios to get lengths.